Hi guys, this is the equivalent expressions test review. I'm going to go over the answers to these, so hopefully you'll be all prepared for your test tomorrow. Alright, number 1, express 9 to the third power as a product of the same factor, then determine the value. So what does 9 to the third power mean? Remember, 9 is your base and 3 is your exponent, and the exponent is always telling you how many times to multiply the base. So I would write this out as 9 times 9 times 9. Now to find the answer to this, I have to multiply. So 9 times 9 is 81, and now I need to multiply again, 81 times 9. So 81 times 9. 9 times 1 is 9. 9 times 8 is 72. So my answer is 729. Number 2, express 2 to the fourth power as a product of the same factor. Then determine the value. So again, it's in parentheses this time, but that doesn't change how I do it. It's still the base, and the base is to the fourth power. That's telling me to multiply the 2 4 times. So 2 times 2 times 2 times 2. Now, don't make the mistake of thinking, oh, that's 8. It's 4 times 2. Nope, it's not. You have to do 2 times 2. That's 4. Then 4 times 2 would be 8, and then 8 times 2 would be what? 16. Okay, see how that works? 2 times 2 is 4, then times 2 is 8, and then times 2 is 16. Number 3, generate an equivalent expression for 5 times 5 times 5 times 5 using an exponent. Then determine the value. All right, so for this one, we're going to rewrite it with an exponent first. So what number is being multiplied repeatedly? That's your base. It would be 5. Then how many times is it multiplied? 1, 2, 3, 4. So that's my exponent. To figure out the answer, I'm going to multiply 5 times 5, that's 25. Then 25 times 5, so if I don't know what that is, I'm going to work that out. 25 times 5. 5 times 5 is 25, carry your 2. 5 times 2 is 10, plus 2 is 12. Okay, but that's just the third one. I still need to multiply by 5 again. So 5 times 5 is 25, carry your 2. 5 times 2 is 10, plus 2 is 12, carry your 1. 5 times 1 is 5, plus 1 is 6. This is equal to 625. Number 4, generate an equivalent expression for 3 times 3 times 3 times 3 times 3 using an exponent, then determine the value. So again, my base is going to be 3. 1, 2, 3, 4, 5 is being multiplied 5 times, so I'm going to write to the fifth power. To find the value of this, I need to multiply it. 3 times 3 is 9. Then 9 times 3 would be 27. Then times 3 again, that would be 27 times 3. 3 times 7 is 21. Carry your 2. 3 times 7 is 6. 3 times 2 is 6, plus 2 is 8. All right, so I've done this one, and then times 3 that last time. 3 times 1 is 3. 3 times 8 is 24. 243. If it confuses you that way, another way to break this up is to do, all right, 3 times 3 is 9. 3 times 3 is 9, so I could do it this way, 9 times 9, and then times 3. That would also work. So 9 times 9 is 81, and then I could multiply 81 times 3, get the same answer. 3 times 1 is 3, 3 times 8 is 24. Okay? All right, generate an equivalent expression for each using the order of operations. So remember, we're using PEMDAS as our order of operations, which stands for parentheses, exponents, multiply, divide, and then add, subtract. All right, so the first thing I would always look for is parentheses. There are none. Then I look for exponents. There are none of those. And then I look for, remember, it's not multiply then divide, it's multiply or divide. So I'm going to look for either of those. This one has multiplication right here, so my first step is to multiply 5 times 2. Nothing else in the problem changes. I want to rewrite it as 16 minus 6. And now I'm going to replace 5 times 2 with the number 10. The second thing I want to do, after I'm done with multiply, divide, I look for add, subtract. Not add or subtract, but, not add then subtract, but add or subtract. All right, so it could be either one. It just depends on which one comes first, just like when you're reading. All right, so this problem has both subtraction and adding, but the subtraction comes first. So we're going to start with subtraction. All right. So I'm going to start with 16 minus 6, which is 10. Then I can bring down the plus 10 and then finish up with that. 10 plus 10 is 20. In fact, sometimes it's easier to write PEMDAS out like this, because that may help you remember it's multiply or divide, and then add or subtract. All right, in problem 6, the first step is to look for parentheses. There are no parentheses. The next thing I look for is exponents. I do have an exponent right here, 4 to the 3rd power, which means what? It means 4 times 4 times 4. 4 times 4 is 16. I need to know what 16 times 4 is. 4 times 6 is 24. Carry your 2. 4 times 1 is 4 plus 2 is 64. So I'm going to replace 4 to the 3rd power with 64. Notice nothing else changed. I rewrote the entire problem. I promise you it is easier to just keep rewriting and not make mistakes than try to skip steps and mess up on simple things. So do it. Take the time to do it. All right, I've done my exponents. My next step is to look for multiply or divide. I have multiply here and divide here. Now this time the multiplication is first, so it gets to go first. 9 times 7 is 63, carry your 6. 9 times 1 is 9, plus 6 is 15. So that would be 153. I rewrite the rest of the problem, 64 divided by 8. All right, I'm still not done with multiply divide. Since they're division, I'm going to do that next. 64 divided by 8 is 8. So now I have 153 plus 8. And the last step is to do this. 153 plus 8 is 11. Carry your 1, 6, 1. So this is equal to 161. Sorry, this is 20. I tell my classes one way to remember is if you get home and you want to go over to your friend's house or you want a snack after lunch, it doesn't matter who you see first, mom or dad, that's who you ask. So as you walk in, if you see multiply first, do multiply. If you see divide first, do divide. Same thing with add subtract. Sometimes we make up names for this. Maybe it's your brother Adam and your sister Sally or something. If you're trying to figure out what to do, you go first, whoever comes first. All right, on number 7, you've got 2 sets of parentheses. So you do the first set first. Then inside the parentheses, you still have to follow PEMDAS. All right, so I've got subtraction and exponents. Exponents come before subtraction, so I need to start with 3 to the 4th power. 3 times 3 times 3 times 3. All right, so I know 3 times 3 is 9, and I know 3 times 3 is 9, so I could do it this way. 9 times 9 and get 81. So this is 81. It's still in parentheses because I'm not done with it. All right, since I still have parentheses, I'm not done with the first step, so I need to do 81 minus 5. So I'm going to borrow from the 8, make it a 7, and then that would be 11 minus 5, which is 6. Bring down the 7. So now I have 76 plus 3 times 7 minus 3. Again, I still have parentheses, so that would be my next step. 76 plus 3 times 7 minus 3 is 4. All right, so I'm done with parentheses. There are no more exponents. Now it's multiply or divide. I have multiplication, so that would be next. 76 plus 12, and then my last step is to add these together. So 76 plus 12. 6 plus 2 is 8. 7 plus 1 is 8. 88. Number 8. 26 minus 18 divided by 3 times 2. All right? So no parentheses, no exponents, multiply and divide are both in this problem. But who do you see first? You see divide. You see Dad. So we're going to start with him. 26, 18 divided by 3 is 6 times 2. Okay, notice the only thing that changed was that. Everything else stayed the same. All right, I still need to multiply. Now it's time to talk to Mom. 6 times 2 is 12, so this becomes 26 minus 12. 6 minus 2 is 4. 2 minus 1 is 1, so my answer is 14. All right, number 9. So number 9, this may look a little different, but this is just another way to write division, and I will wait till the end to divide. So I'm going to work out the top and work out the bottom, and then my last step will be to divide those two numbers. So on top, I treat it like its own problem. There are no parentheses, no exponents, but there's multiplication. 5 times 4 is 20. So now I have 2 plus 20. On bottom, I can go ahead and start this problem. What's 10 minus 8? 2. All right, I still need to finish up the top. The numerator, 2 plus 20 is 22. This is 2, and this means divide. It's just another way to write division. 22 divided by 2 is 11. So my answer is 11. All right, and the next section, we're supposed to match the expressions to the property used. So make sure you remember your properties. In this first one, 24 minus 16 minus 8, and 24 minus 16 minus 8. Now, this one's a little tricky because it looks a lot like the associative property. Associative property changes the way things are grouped. Here, the 16 and the 8 are grouped together, and it changed here. The 24 and 16 are now grouped together. But the associative property doesn't work for subtraction. It also does not work for division, so don't let that trip you up. These are not equivalent. And you could test that if you wanted to by going ahead and subtract. We'll skip that for now. All right, 11, 9 times 8, and 8 times 9. Those are definitely equivalent expressions because you would get the same answer if you multiplied. But what property is that? Well, what actually changed was the order. Here the 9 was first, but here the 8 is first. So this is the commutative property because it changes order. Remember commuting back and forth to someplace. You go to the bank and then you come back. You just changed the order of how you got there. All right, 12. Again, this is grouping. You can see with the parentheses, 5 plus 9 plus 2. Here it's 5 plus 9 plus 2. The order is not the same. It's 5, 9, 2, 5, 9, 2. But what changed was what was in the parentheses. Okay, that's association. It's who you hang out with, who you associate with. That would be C. 7 plus 0 and 7, definitely, those are equal to each other. When you add 0 to something, you always get the exact same number, right? That's your identity property. It's identical to what it started with before you added the 0. Okay? All right, turn that over. Number 14, we're finding the prime factorization of 180. So for prime factorization, we're using a factor tree. We need 2 factors of 180. I'm going to just start with 18 times 10. I know that because it ends in a 0, I can multiply something times 10 to get 180. Neither one of these are prime, so I need to keep going. All right, I know that 9 times 2 is 18, and I know that 2 times 5 is 10. I'm going to circle my prime numbers. I know that 2 and 5 are all prime, so I'm going to circle those 3. 9 is not a prime number, so I need to keep factoring. I know that 3 times 3 is 9, so these are my last 2 factors. And then I want to rewrite this in expanded form. So I'm going to always start with the smallest factor, which was 2, and there are 2 of them. So 2 times 2, and then the next factor, smallest factor, was 3. There were 2 of those also, and then times 5. And then I want to write it in exponential form as well. So now I'm going to go back, and for any factor that's repeated, I'm going to write it with an exponent. So that would be 2 to the 2nd power times 3 to the 2nd power times 5. All right, so you need to know how to write it either way. For 15, I'm starting with a negative number this time, so negative 48. Remember, when there's a negative, I'm going to just rewrite this first as negative 1 times 48 so that I don't forget about the negative 1. I need to make that part of my expanded form and my exponential form. All right, and then now I'll just do 48 like a regular factor tree. So I need 2 factors that give me 48. I might start with 2 and 24. Now you might pick 2 different factors, and that's fine. Your final answer should be the same as mine. So 2 is prime, 24 is not. I know that 24 is 6 times 4. Neither one of these is prime, so I'm going to keep going. 2 times 3 is 6, and 2 times 2 is 4. These are all prime now. So I'm going to circle those so I don't forget them, and then I'm going to rewrite it. So I've got a negative 1. And then there are 1, 2, 3, 4, 2. So 2 times 2 times 2 times 2. And then my last factor was 3. In exponential form, I still have the negative 1. The only factor that repeats is the 2, so it's the only one that needs an exponent. There are 4 of them, so 2 to the 4th power times 3. Number 16. What number has the following prime factorization? 2 to the 3rd times 5 to the 2nd. So if I write this out, if I expand this, 2 to the third power means 2 times 2 times 2, and 5 to the second power means 5 times 5. All right, so I know that 2 times 2 is 4, and 4 times 2 is 8. So I know that this gives me 8. I know that 5 times 5 is 25. So now I can just multiply these two together. 25 times 8 is 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. So this is a total of 200. Number 17, which number has the following prime factorization? -1. Ooh, that tells me my number is going to be negative. Don't forget that. And then 2 times 2 to the second power tells me that that's going to be 2 times 2. And then there's 1, 3, and 1, 5. All right, so I know 2 times 2 is 4. I know that 3 times 5 is 15. So to save myself a couple of steps, I'm going to take that shortcut. 5 times 4 is 20. So I'm going to carry that 2. 4 times 1 is 4 plus 2 is 60. And then don't forget, because it's negative, this is actually negative 60. For each number, place it in the Venn diagram and then classify it. Circle all the sets to which it belongs. So I have a -7. -7 is an integer. It would go right here. Because it is an integer, I'm going to circle integer. And then integer is inside rational, so it is also a rational number. All right. It's negative. It looks like a whole number, all right? But because it's negative, it's an integer. 19, 3 and 1/5. 3 and 1/5 is a rational number because of the fraction. So it is only rational. It's not inside any of these others. 20. I'm sorry, number 20 is 4. 4 is a natural number. It's a number you learn to count with, so it goes in the natural numbers. Because it's in the natural numbers, it's also in the whole numbers. And it's also in the integers, and it's also in the rational. So 4 is all of those. 21 is -4.6. 4.6. Now, sometimes this tricks people because they see the negative and they think it's automatically an integer. That integers have no decimals. Integers are just negative and positive whole numbers. So you can't have a decimal in an integer. So if it's a decimal or a fraction, it's automatically only rational. So that's the only thing you should circle there. 22, express -5 and 7/20 in decimal form. So right away, I'm going to write -5 point something so that I don't forget the whole number or the negative sign. But I still need to change 7/20 to a decimal. And I do that using Tybo. So remember, Tybo means top in, bottom out. So the top number is 7. The bottom number is 20. I can't divide 20 into 7. So I'm going to hold it with a 0, even though the -5 is actually going to be in front of my decimal. I'm going to add a decimal, bring it up, and add a 0. 20 will go into 70 3 times. 3 times 20 is 60. When I subtract, I get 10. I have a remainder, so I need to keep going. So I'm going to bring down another 0. 20 will go into 100 5 times. 5 times 20 is 100. So I'm done. The 0.35 I'm going to add over here with the -5, and my final answer is -5.35. 23, order the set of numbers from least to greatest. So when I'm ordering numbers, I want to make sure that I change everything to the same form. So I'm going to change my fractions into decimals first. So again, I'm using Tybo. I'm going to write my negative here so I don't forget about it. And then the top number is 7. The bottom number is 9. I cannot divide 9 into 7. So I'm going to hold a 0 there and add a decimal up and down. I'm going to add a 0 next to my decimal. 9 will go into 70. What is that? Let's see, 7 times. 7 times 9 is 63. When I subtract, I have to borrow. 10 minus 3 is 7. I have a remainder, so I need to add another 0 and keep going. 9 will go into 70, 7 times. 7 times 9 is 63. Oh, what's happening? I'm going to get that same remainder over and over. So this is a repeating decimal. So this is -0.77, and you can repeat the first 7 or you can put it on the second one. Then I have 0.78. I'm going to line these up so that I can see them. 3/4 right here is a fraction, so I want to change that to a decimal. So top in, bottom out. Top is 3, bottom is 4. 4 will go into 3. It won't, so I'm going to put a 0 here, add a decimal on top and bottom, and another 0. 4 going to 30 7 times. 4 times 7 is 28. When I subtract, I get 2. Since I have a remainder, I'm going to keep going. 4 going to 20 5 times. And then I can stop. So my answer here was 0.75. And then my last number is already a decimal. Don't lose those negatives though. All right. So I have a problem here before I will keep going. Now that they're all decimal, I can see, and they're lined up, that there's something different about this one. And what would that be? It's got 3 digits where the rest of them have 2. And I don't want that. I want them all to have the same number of digits so that I don't make any mistakes. So when that happens, and sometimes I add 0. So here I'm going to add a 0, and here I'm going to add a 0. But what about this one here? Because it's repeating the 7, there are no zeros out here. They're all 7. So I'm going to add another 7 here. All right, then I need to put these in order. I'm going least to greatest, so I want to start with the smallest one, which would be my negatives. So which one is the biggest, or which one is the most to the left on my number line? Well, it's actually what looks like the largest negative, because as you get to 0, those numbers seem to get smaller with the negatives. So I'm going to start with negative 0.77, and then negative 0.712. All right, then once I get to 0, past 0, I have my positive numbers, and then it's just regular. Which one is next? The 0.750, and then a 0.78. All right, and the last thing I'm going to do is write this back in the original form. So 0.77 was negative, originally negative 7/9. Negative 0.712, that's what it started as, so I will leave it like that. 0.75 was originally 3/4. And 0.780 was really just 0.78. So you want to make sure you know how to rewrite those. Even though there's nothing wrong with this, you're most likely to see this as an answer on a test. All right, so good luck on your test, and I will see you soon.